Hello, good evening, friends. So, today we will continue the topic which we have left in the last class with respect to introduction to earthquakes. So, in the last class, we have seen what are the requirements of an efficient earthquake system, what are the requirements. So, in today's class, we will see about dampers and what you mean by damping. So, I'm sharing the screen. I hope it is visible to you. If not, you let me know. So damping devices or base isolation system. So what exactly is damping in earthquake? Damping is a very important parameter with respect to earthquake. So we'll study this in detail today. What is damping in earthquake? The study of decrease of successive amplitudes of vibration of a structure by the dissipation of vibration energy is known as damping. So what exactly is damping? The study of decrease of successive amplitudes. So amplitudes, you are familiar with it. You have already studied this in your physics at PUC level. Amplitude, frequency, vibration and all. So what is happening in case of damping is the study of decrease of successive amplitudes. The number of amplitudes is decreasing as the vibration increases. The study of decrease of successive amplitudes of vibration of a structure by dissipation of vibration energy. Which type of energy is being dissipated? Vibration energy. Due to this dissipation, there is a decrease in the amplitude. This entire process is known as your damping. This link can also be used by you to know exactly what is damping. I have shared the link. You can see it whenever you are free. Now we will see what are the different types of dampers or damping devices. So the first type of damper is viscous damper. So what do you mean by viscous damper? So in viscous damper, seismic energy is absorbed by silicon based fluid passing between piston cylinder arrangement. So what is happening in case of viscous damper? The seismic energy is being absorbed by whom? By a silicon based fluid which passes through the piston cylinder arrangement. These viscous damper are used in high-rise building in seismic areas. So as you are familiar that earthquake is most likely to occur in zone 4 and 5, which are also known as earthquake prone zones. These viscous dampers are used in zone 4 and 5, where the structures are generally high-rise buildings. So it can operate over an ambient temperature ranging from 40 degrees Celsius to 70 degrees Celsius. So what is happening is uh, it can operate over an ambient temperature ranging from 40 degrees Celsius to 70 degrees Celsius. So what is the temperature we are getting? Hello, I am audible. So there was a technical problem. So we will continue our discussion on viscous damper. So viscous dampers, as I said you, they are used in high-rise building in seismic areas, and it can operate over an ambient temperature ranging from 40 degrees Celsius to 70 degrees Celsius. So what is the temperature range which we are expecting in which we can use viscous damper? 40 degrees Celsius to 70 degrees Celsius. That is more than the room temperature. The viscous damper reduces the vibration induced by strong wind and earthquake. So, what is the purpose of using viscous dampers in high-rise buildings in seismic areas? Because they reduce the vibrations which are induced by both strong wind and earthquake. It reduces the vibrations, as a result of which the amplitudes also decreases. Now, second type of damper are known as viscoelastic dampers. Another type of damper is known as viscoelastic damper that stretch an elastometer in combination with metal parts. So what is happening? And that in viscoelastic damper, as the name itself indicates, viscosity as well as elasticity, both the parameters are taken into consideration into this. So what is happening in case of viscoelastic dampers? They, as you stretch the viscoelastic damper, and elasticity is produced in the damper. So it is a combination of viscosity as well as elasticity. This type of damper dissipates the building's mechanical energy by converting it into heat. So this phenomena is somewhat different. What is happening? How the dissipation of energy is taking place? This type of damper dissipates the building's mechanical energy by converting it into heat energy. Apart from this, several factors such as ambient temperature and the loading frequency also affect the performance and consequently the effectiveness of damper system. So what are the factors that affect these viscoelastic dampers apart from the temperature? As we have seen just now in case of uh, viscous damper, the temperature was maintained around 40 degrees to 70 degrees Celsius. Here also some temperature is maintained, but apart from the temperature, another factor such as loading frequency, how the load is being applied to the dampers, and also the performance and effectiveness of the damping system is affected by temperature as well as loading frequency. These viscoelastic dampers have been successfully incorporated in a number of tall buildings as a viable energy dissipating system to surpass the wind and earthquake induced motion of building structure. So, as the viscous dampers are used in high-rise buildings in zone 4 and 5, these viscoelastic dampers are also been successfully incorporated in number of tall buildings where the energy dissipation has been taking place and the effect of wind and earthquake induced motion of the building is reduced. Last but not the least, friction dampers. Generally, a friction damper device consists of several steel plates sliding against each other in opposite direction. So why the name friction dampers is being given to this type of damper? What is happening? As in the case of friction, i- this friction damper consists of several steel plates which are sliding against each other in opposite direction, as a result of which frictional force is produced between the two. These steel plates are separated by shims of friction and material. The damper dissipates energy by means of friction between the surface which are rubbing against each other. So as in case of viscoelastic damper, viscosity and elasticity was the reason for dissipation of energy. In case of friction damper, friction is responsible for dissipating the energy. So how it is happening? The damper dissipates energy by means of friction between the surface which are rubbing against each other. It is also possible to manufacture surfaces from materials other than steel. So normally we are explaining about steel with respect to friction dampers, but apart from steels also, other surfaces can also be used as friction dampers, not restricted to steel. Now, base isolation. What exactly is base isolation? We need to understand. A base isolation system is a popular system implemented in a structure to protect it from the action of seismic forces. So, what is base isolation system? It is a popular system implemented in a structure to protect it from the action of seismic forces, or in other words, you can say earthquake. So, base isolation system is very important in case of buildings which are present in zone 4 and 5 where the chances of earthquake is more. So this system, that is base assessor system, was developed by Dr. Bill Robinson in the 19th centuries in New Zealand. So who developed this system? Dr. Bill Robinson in the 1970s. He designed it. Who in the country New Zealand. A base isolation system is used as a damage resistant seismic design solution for both new and retrofitted building. So this a base isolation is used to as a damage resistant seismic design solution. So normally we what we think is, as dampers are used to dissipate the energy or reduce the effect of seismic energy, base isolation might be the same, but there is difference to it. What is the difference? A base isolation system is used as a damage resistant seismic design solution for not only new but also retrofitted building. If you are constructing a new building, then also you can provide base isolation system. If already a building is being constructed, retrofitting of the building can be done, and after that also base isolation system can be used. This system is hence named as seismic base isolation system. Because we are reducing the effect of seismic forces, base isolation system is also known as seismic base isolation system. Now, how exactly this works? That is the working principle of base isolation system. The fundamental principle of a base isolation is to alter the response of the building structure so that the ground below it can move easily without transmitting these motion forces to the building structure above. So how base isolation system work? As we have studied in case of viscoelastic dampers, viscosity and elasticity was the reason, and in case of friction dampers, friction was the reason. How this base isolation system works? The fundamental principle is to alter the response of a building structure. So what do you mean by response of a structure or response of the building structure? Suppose an earthquake occurs in X direction. So what will be the reaction of the building in Y direction? Or in other words, you can say what will be the response of the building during an earthquake. So what the building is doing during an earthquake? The response of the building is such that the ground below it can move easily without transmitting these motion forces into the building structure above. So what this base isolation system is doing, it is minimizing the effect of seismic forces, and it is not allowing the seismic forces to move to the upper floors. It is vanishing the effect of earthquake at the bottom only. How it is done? This is achieved by separating or isolating the superstructure from its substructure, that is resting on a shaking ground. Thus, the structure has less effect due to earthquake forces. So, as you know that a structure consists of substructure, superstructure, and slab. So, what this base isolation system is doing? It is isolating the superstructure from its substructure during an earthquake. So, whatever effect of earthquake is there, it is only restricted to the substructure. It is not being transmitted to the superstructure. Now, the term isolation itself refers to the reduced action between the main structure and the ground. So, base isolation system, the name itself indicates or gives the explanation for it. It is isolating the base from the bottom or from the ground. When the system is provided under the structure, it is called base isolation system. Now, the base isolation comes under passive vibration control energy in earthquake engineering. So, as you know that there are two types of control, active control and passive control. So, active vibration control and passive vibration control. This base isolation comes under passive vibration control in earthquake engineering. It is a design strategy that serves the purpose of uncoupling the structure from the damaging effects of the earthquake ground motion. So what is happening? This base isolation is a system is a design strategy that serves the purpose of uncoupling the structure from the damaging effects of the earthquake ground motion. So what it is doing? It is bifurcating itself, or it is isolating itself from the superstructure during an earthquake. The decoupling action of the base isolation makes the building behave more flexible, thus increasing its resistance against the earthquake. Suppose a building is rigid, what will happen is during an earthquake, the substructure will remain at its place and the superstructure may vanish. But if the building is flexible, as it is the case in base isolation system, what is happening is As the building is behaving flexible, it is increasing the resistance of the building against the earthquake. So the principle can be more clearly explained by considering an example. Consider a building resting over frictionless rollers. See here, what we are assuming? We are assuming a building which is resting on frictionless rollers, because as we have seen that friction also plays an important role in case of damping. We are using rollers which are frictionless. No friction is between them. So consider a building resting over frictionless rollers. When the ground below the building is subjected to shaking, the rollers start to freely roll, but the building stays above without any movement. So what we are trying to tell is, as we have studied about base isolation system, what we are trying to explain is the base is isolating or substructure is isolating and is not affecting the superstructure. Suppose when the ground below the building, this red portion is subjected to shaking, what will happen? The rollers will start to freely roll, but the building which is above these rollers stays without any damage or without any movement. Now comes the question where to locate these base isolators. Locations of base isolators in buildings. Generally, the isolators are installed at the top or bottom or mid height of the building basements, columns, and the walls. If not, a diaphragm is immediately placed above the isolator. So now till now we have studied about what do you mean a base isolation system. Now comes the question whether we need to provide dampers or base isolators. Remember the thing, dampers are different and base isolators are different. Dampers are used to dissipate the seismic energy, whereas base isolators are used to minimize or reduce the effect of earthquake during an effect on the building during an earthquake. So where these isolators are provided? These isolators are installed at the top or bottom or mid height of the building basement. So they are provided at the basement, columns and at the walls. If suppose if it is not possible, then a diaphragm is immediately placed above the isolator. The placement of base isolators must be done in such a way that the building must be able to move horizontally relative to the below ground for a distance not less than 100 mm. So now the question comes, what is the limitation? Up to how much distance you can move the building? So the placement of base isolators must be done in such a way that the building must be able to move horizontally. What we are seeing with respect to this figure, when the ground below the building is subjected to shaking, the this dotted portion is the ground. If it is subjected to shaking, the rollers will start to freely move, but the building stays above without any movement. Up to what distance? Up to 100 mm. Now, below are the example which shows some of the possible locations of the base isolators near the substructure. As we have discussed that base isolators are provided at the substructure or at the basements. So in the first figure, if you see, the isolators are provided. New foundation is there. Above the new foundation, this black portion is nothing but your isolator. This is in case of under foundation. If suppose on foundation, at the foundation, we need to provide the isolator, base isolator. So this should be the sketch. Isolator, new foundation beam. If suppose we need to provide the isolator at the base column, so this should be the arrangement. Separation of exterior wall, and in between the two we can provide the isolator. Finally, at middle story column, if suppose at the middle we want to provide the isolator, then also we can provide it. So there are possibly four cases with the help of which we can provide the base isolators near the substructure. So this completes our module 1. We will just have a recap of this, and in the next class we will go to module 2. So we started with the introduction to engineering seismology. Apart from this, general features of earthquakes with regard to Indian continent we have studied. Geological and tectonic features of India also we have studied. Origin and propagation of seismic wave. How the seismic waves are originated, how it is propagated, that we have seen. Next, in the characteristic of earthquakes, magnitude, intensity, scale, seismic instruments. So what are the characteristics of earthquake? How it behaves during an earthquake, how a building behaves during an earthquake, that we have studied, and how the magnitude of an earthquake is calculated, with how the intensity of an earthquake is calculated. That we have also seen using say various type of scales and seismic instruments. Apart from this, we have also seen earthquake hazards in India. What are the most renowned earthquake that occurred in India in the past century, and how the earthquake risk can be evaluated and how it can be mitigated. That also we have seen. Next, structural behavior under gravity and seismic load. So with the help of a tabular column, we have differentiated how structure behave under the application of gravity and seismic loads. Next, we have seen lateral load resisting structural system and what are the requirements of efficient earthquake resistant structural system. What are the requirements, that also we have seen. Finally, we have seen about damping devices, elastic dampers, and friction dampers. And last but not the least, we have seen about base isolation system also. So it's all started with the introduction part. What even by seismology, engineering seismology, that we have seen. Apart from this, what is the purpose of using a studying seismology, that we have seen. So, what is an earthquake? Earthquake is the vibration of earth produced by the rapid release of accumulated energy in drastically strained rocks. This definition also we have seen. So, what are the causes of earthquakes? Generally, an earthquake occurs due to movement of tectonic plates, that we have seen. Apart from that, faults are also responsible for earthquake. So, how the earthquake occurs with respect to focus, epicenter, hypocenter, all this we have seen in detail. After that, we have seen type of seismic waves, P waves, S waves, primary waves, secondary waves, how they behave, what are the speeds, that we have seen. Surface waves. So the characteristic of earthquakes, how an earthquake occurs, it is generally measured in terms of two ways. And first is with respect to magnitude, next is with respect to intensity. MMI scale we have seen, seismometer we have seen. So in 1935, normally when an earthquake occurs, we hear that on the Richter scale, it has been noted as the magnitude of earthquake is this much. We have heard in news and all. So what exactly it is? It is named with the name of Charles P. Richter, who proposed an equation in the year 1935. That is m equal to log a minus log a naught, where a is the recorded amplitude in micrometer, a naught is the amplitude of standard earthquake. So what exactly is a seismograph? Or it is an instrument used to measure the magnitude and intensity of earthquakes, that we have seen in detail. So after that, we have seen what are the known earthquake hazards in India with the help of tabular column. And also there is a warning that by 2050, there will be 200 million cities in India that will be affected by earthquake. So which code is used for earthquakes design? It is IS 1893 Part 1 2002. That is normally the code we are using nowadays. After that, we have seen what are the different zones in which the entire area of India is divided. Initially, it was divided into four zones with zone 1, 2, 3, and 4. Later, it was modified and zone 1 was removed. And finally, it comes down to zone 2, 3, 4, and 5. According to the present zoning map, zone 5 is the highest level of seismic area, whereas Zone 2, in which we are laying, is the lowest level of seismicity. So what are the regions that comes under zone 2? That is Bangalore, Ajmer, Allahabad, Hyderabad and Pondicherry. As we know that we are in zone 2 only. In zone 3, areas of say, Kerala, Goa, Lakshadweep Island, remaining parts of Uttar Pradesh, Gujarat, all Andhra Pradesh, Tamil Nadu, and few parts of Karnataka will come. In the zone 4, which is also known as highest damage zone, in this, it comes in the Maharashtra, the Patan area, in Bihar, Raxol, and Jammu and Kashmir, Himachal Pradesh all comes under zone 5. Finally, zone 5, which is the highest or more prone zone, is also known as high damage risk zone. So what are the regions that comes under zone 5? The Kashmir, the western and the central Himalayas, the north and middle Bihar, the northeast Indian region, the run of Kutch and Andaman and Nicobar, all these fall in zone 5. So what is the type of rock that is available in this type of zone? The areas will have trap rock or basaltic rocks. So this is the what you can say place, depth, date, time, and year, magnitude, epicenter. In a nutshell, you will understand what are the different earthquakes that have hit India over the past century. The maximum deaths were recorded in the year 2004 in the western coast of Sumatra, Indonesia. The earthquake occurred on December 26, 2004. It is also known as tsunami. More than 283,000 people died. Now, after that, we have calculated how the earthquake risk and evaluation is done, how to evaluate the earthquake and how to evaluate that we have seen, how to reduce the effect of earthquake, minimize the death that we have seen. For that, earthquake risk and design of structure should be done, how the earthquake should be. After that, we have studied what is the structural behavior under gravity and seismic load with the help of a tabular column, how the structure behave under gravity and seismic load that we have seen. Gravity load is lateral loading, bending moment, shear force. After that, we have studied about lateral load resisting system, which consists of movement resisting building frame system, shear wall or bearing wall system, and dual system. Dual system is the combination of the above two. Let's see here, and the whole shear walls are present. The lateral frames, 25% lateral load minimum is reduced. Next, we have studied requirements of efficient structure, how the structure should be with respect to its shape, symmetry, and all. And there should be no uh, deformation. It should not be discontinuous. The building and its superstructure should have uniform and continuous distribution of mass, strength, stiffness, strength, and ductility to avoid overstressing of structural components due to stress concentration. If you see here, superstructure, substructure, first ground floor, second floor. The structure should have good lateral load resisting system and direct pathway without discontinuity. Last but not the least, integral action of soil. How the soil should be that we have seen. And the superstructure should be compatible with respect to stiffness and all. And it should be have a be detailed for adequate ductility. Ductility is also a very important factor. Today we have seen damping devices. What exactly is damping? It is nothing but the study of decrease in successive amplitude. How, why, what is the reason for decrease in amplitude? The dissipation of energy, vibration energy. Next, we have seen viscous damper, in which the temperature ranges from 40 to 70 degrees Celsius, and it is used in zone 4 or zone 5, where the high-rise buildings are present. Whereas viscoelastic dampers, viscosity as well as elasticity is the reason. Apart from the temperature also plays a very important role. Finally, we have seen about friction damper, in which friction is the main culprit. Apart from steel plates and other materials can also be used for friction dampers. Last but not the least, we have seen about base isolation system, which was developed in the year 1970 by the scientist Dr. Bill Robinson of New Zealand. So what exactly this base isolation system does. It isolate the base from the from the structure, or it is generally present at the what you can say basement's wall a column. So it is isolating itself from the superstructure, as a result of which the building will start moving in horizontal direction. Up to how much distance it should move, it is minimum allowed is what you can say is 100 mm. So which can also be studied or understood with the help of example. What we are doing, we are considering a building resting over frictionless rollers. When the ground below the building, that is this blue portion, dotted portion, if it is subjected to shaking, the rollers which are free from friction will rotate, and the building above it will move without any movement. So at what point or where these isolators are provided? They are provided at the bottom or mid height of the building columns and the wall. If not, everyone is immediately present of the isolator. So this figure gives a clear explanation about base isolators. So in the next class, we will continue. Hope you have understood.